Environment diagrams are a fantastic way for us to visualize the steps that a Python program takes. I'll be going over this in a lot more depth in discussion 2, so this is just a brief introduction. To draw an environment diagram, you'll follow the exact same steps every single time. So to begin with, we'll be looking at assignment statements. Over here are the steps for assignment statements. So to begin with, in the first assignment statement, step 1 tells us to evaluate the expression on the right side of the equal sign to get a value. So the expression on the right side of the equal sign is 11 mod 4, and that evaluates to 3. In step 2, we need to check whether the name x already exists in the current frame. Now, in environment diagrams, you'll have two columns, a column that keeps track of all your frames and another column which keeps track of all your objects. With environment diagrams, you'll always begin with the global frame. We'll explore the significance of this in discussion 2, but all you need to know for now is that we always begin with the global frame. Because the name x doesn't exist in the current frame, we can bind the new name to the value. In other words, we bind x to the value 3. Then, looking at assignment statement 2, we evaluate the right side of the equal sign, and over here, this time, we're encountering a name. So we need to search the current frame for that name. And we search the current frame, and we do find x, and x stores the value 3, so we know that this evaluates to 3, and we can go to step 2 now. In step 2, once again, we need to check whether the name y exists in the current frame yet. It doesn't, so we bind y to the value 3. The last assignment statement is equivalent to x equals x to the power of 2. Step 1, we evaluate the right side of the assignment statement. We encounter the name x. We search the current frame for the name x, and we find that x stores the value 3. So then this evaluates to 3 to the power of 2, which evaluates to 9. Now step 2 wants us to check whether x already exists in the current frame, and we find that it already exists in the current frame over here. This time, we need to erase the current binding, so we erase the 3 and bind the name to the value we recently got, which is 9. So that's the environment diagram for these assignment statements. Moving on to def statements. So every time you see a def statement, it'll follow these steps. So to begin with, once again, we have a column for frames and a column for objects. And line 1 is a def statement. Step 1 tells us to draw the function object with all this information. To begin with, we need func. The intrinsic name of a function essentially means that it's the original name of the function. It's the name of the function when it was created. So over here, we're creating a function, so the intrinsic name is double. Formal parameters is just what it takes in, so that's x, and then we need the parent. So just like I mentioned before, we always start with the global frame, and over here, we know parent is global. For step 2, we know that the intrinsic name of this function doesn't exist in the current frame yet, so then we write it in, and we bind the newly created function object to this name. For a triple, we do the exact same thing. So we have func, this time it's called triple. It takes in parameter, it has a parameter of x, and the parent is still global. Once again, this intrinsic name doesn't exist in the current frame yet, so then we can write it in and bind the function object to this name. Then in the next line, we see an assignment statement. So this would follow the rules that we looked at before. So step 1 tells us to evaluate the expression on the right side of the equal sign, and we encounter a name. So this means that we search in the current frame for that name, and we find that name over here. And it points to this object over here. Moreover, the name hat doesn't exist in the current frame yet, so then we can write it and bind it to the object. Finally, in the last assignment statement, we see triple, which refers to this over here, and that points to this object. However, this time, the name on the left side of the assignment statement already exists in the current frame. This means that we should erase the current binding of double because it already existed, and we bind it to the value, the object from triple.